It's time to wrap up Chapter 2. Most of our units that we go through don't have as many as 10 lessons, but in fractions and decimals and things like that, there's a lot of different things I need to know. We have to just cover those basic 4 functions, adding, subtracting, multiplying, and dividing, but then there's all sorts of different ways to look at them. And being able to build a foundation where I understand my math and numbers and how they're related, that's the key to the whole thing. I've said from the beginning, just being able to get your assignment done is not it. Understanding what we're talking about, being able to expand upon that base and build upon it is what it's all about. I want you to understand math and be a better mathematician than when you started my class this year. Maybe you're really struggling in math in the past couple of years and you feel like you're the lowest of the lows when it comes to understanding math. You'll get much better if you're participating with my class, following along, engaged with me, listening to me, and thinking about what I'm talking about. If you were the highest of the high in 6th grade, you will still become a better mathematician if you're following along and thinking about what I'm talking about. I have a couple of you that are really good with math, and while you're playing the video, you're working on your homework. You're not engaged in what I'm saying, and so you're missing some of the key points. I know I do extra talking. I purposely do extra talking because I'm explaining some fundamental things that I want you to think about and apply, and you'll get better in math. But the whole key, as I've said a couple times already, it's about thinking. How is this related to this? What do they mean by this? I'm going to be giving you a piece of paper that some of you may not use because you really get these story problems, but some of you, story problems are like, you know, the term of it's my Achilles heel because Achilles was shot in the heel, tore his Achilles tendon, you know, and he was no longer a great hero. Story problems, every math problem you do is great until you get to the story problem and you're like, I hate story problems. Well, generally story problems are going to be exactly what I saw last night. We skim through it and we get to an answer, and then sometimes we look at that answer and we think, oh, that's not logical. Sometimes we get to questions like number 9 last night and you see the answer that I told you it should be and your answer is completely off. Now, I want to be honest with you, okay? As I've told you, I have 3 college degrees. In my undergrad years, I was going to be a math teacher, but I changed. So I actually have a minor in mathematics. I know math, I understand math. And when I was first working through last night's homework to do my answer key, I got the answer wrong. And I looked at the book, I'm like, how in the world did they get that? The book must be wrong. And then I paused and I thought, well, maybe I didn't read it very close. And I realized I just skimmed through the math problem and I got the wrong answer. So when I asked you yesterday, when you said, I don't get number 9, I want to see how you got that answer. And I asked, did you read the problem? Yes. Okay, so reading is just like listening. Your eyes can read and your brain can be engaged in something else, and you're not actually comprehending what you're reading. To where, if you slow down and you engage your brain, just like the listening, ears are working and brain is engaged, you're going to learn something different. And there were 5 of you that came back and said you were struggling with it. And when I had you actually read it out loud to me, when you got to the part that they worked 8 hours a day, Monday through Friday, okay. You understood what you had done. You'd skimmed through and saw numbers. You didn't actually listen to yourself reading the question. And when you realized that there were 8 hours a day for 5 days, you knew exactly what you needed to do. We got to think about math, and that's the whole key to mathematics. So for example, following along is so important. If you follow along and you're paying attention, you're going to build this muscle memory and realize that almost all of these problems work the exact same way. They're a 2-step math problem. If I would write it out as a math problem, it would look like this at the beginning. What the individual has, or the animal has, or whatever we're talking about. What is left over at the end, and that's usually the way it's introduced to you, but there's something that they throw in there in the middle, and they throw it in the middle to try to confuse you. So if I'm reading it and thinking about what I have, what I'm left with, and then I know that I have it in equal groups, my math becomes easier. The 2-step math problem is I have to have a parentheses set up in my mind. You don't have to write this out, you just have to start with doing this math. what the individual has in their possession and what they're going to have left over at the end. Subtracting those, finding the difference between them, and then I can look at what was actually used and put it into my equal groups. All right, so let's see what exactly that means. I'm not trying to confuse you, I'm just trying to explain to you that every single one of these is going to be set up the same way. So the question is about granola, right? So we have Sam, he has 3/4 pounds of granola. We know that he's going to have taken every day that he takes granola 1/8 pound, and then at the end he has left 1/4 pound. So the question is, well, how many days did he take granola? So I have to start. This is my thinking pattern once again, and I've put the white box there. You can write on top of the extra little blue boxes and information they've given you, or get notebook paper. Either one works. But my thinking pattern is the way I'm going to think every single time I'm doing these problems. What am I trying to find? Well, here it's asking me how many days did he take granola. Okay. In order to do that, then I know I have to know how much granola he has, what we're in possession of. He has 3/4 pound, right? So if I have 3/4 pound, that's what I'm going to start with. I also need to know how much did he take every day. If it's a different amount, then it's going to completely throw off my answer. But here, Sam is pretty consistent. He's taking 1/8 pound every single day. Then once I have that, he took the 1/8. Well, what was he left with? He had 1/4 left over. So if I know that that's going to be left over, I have all the information that I need to be successful with this math problem. So I have to think about what I'm going to be doing. What is it that they're asking me to do? As I think through it, I know some information. I know he had some left over, so I have to know what he started with and subtract it from what he has left over, right? I also know then that he puts them into equal groups. And anytime we have equal groups, we know that's division. So when I give you a form, and I'm actually going to give you a paper copy, I'm going to attach it to the announcements in math, that anytime you have story problems, it gives you the symbols like a multiplication sign with all these little words inside that are saying, if you see these words with your numbers, then most likely it's multiplication. Or it gives you an addition sign, and it shows all you these little words, and those little words would tell you it's addition if you have them in the story problem. Thinking about what this information is telling me helps me solve the problem. So I know that I'm going to subtract first, and then I'm going to divide. So what am I subtracting first? I have to know what I have, and I have to take away what's left over. So what's the amount in the middle? So what do I have? I have 3/4. How much is left over at the end? Well, that is my 1/4. So now I have fractions that I'm going to subtract. Can I subtract fractions? Yes, I can. Do I have a common denominator? Yes, I do. So when I look at my fractions and I subtract them, I keep my denominator of 4. I subtract my numerators. 3 minus 1 is 2. And 2/4 will always reduce down to 1/2. Once I have that, now I have to know, well then, every one was put into how much in its group. Well, I have the 1/2. And if I know how much I have, then I can take it and I can easily divide it into its equal groups. So I take my 1/2 and I'm going to divide it. My equal groups in this case is 1/8. Can I divide fractions? Can't do it, can I? We've been doing that now for an entire week. So I know my steps are going to be, I'm going to keep my first one, I'm going to change my division to multiplication, and then I'm going to flip my second fraction. So I'm going to keep my 1/2, division will become multiplication, and 1/8 is going to flip and get my reciprocal, and it becomes 8/1. Now I have multiplication, and I know I can multiply. I know I can cross-reduce first to get smaller numbers, which makes my life easier. Ones will automatically become 1, so there's no use in changing those. But the 2 will go into 2 and into 8 evenly. So I'm going to reduce, dividing top and bottom by the same number. 2 would go into 2 one time, and 2 will go into 8 4 times. Now I'm left with multiplying across. 1 times 4 is 4, and 1 times 1 is 1. 4/1 is what? Well, that's just my whole number, right? I can't have a whole number over 1. That only works when I'm using it in a math problem. So I have to put my answer as 4. For what? Several assignments that I graded last night had story problems without labels. Every story problem has to have a label, so make sure we include our labels in our answer so that we get all 3 points. So I showed my work, I get 1 point, I have my correct answer of 4, I get 2 points, and I have my label, so now I have 3, and now we're going to move on. So now we're looking at the next one where it says, try another problem, and we're talking about Mr. Burrows, who's a science teacher. In his experiment, he's going to divide 2/3 cup of salt into small jars, each containing 12 cups. If he has 1/6 of a cup of salt left over, how many jars does he fill? What am I looking for? How many jars? That's what it asks in the final question. What information do I need to use? I need to use how much he has to begin with, what is in his possession. So I know he has 2/3 cups of salt. I have to know, well, how many or what size is the group going to be divided into, and I can see that each container is going to be 1/12 of a cup. All right, so I know I'm going to divide it into 1/12. What does he have left over? Having left over, then he has 1/6 of a cup. So that's the amount of salt left over. If that's the case, then I know I have to start with what I have and what I have left over to see how much was used. That's got to be my first problem. So as I'm thinking about it, I know that I had some and I had some left over, so I'm going to subtract. And that, once I have that answer, I'm putting it into equal groups. So I'm going to divide. So subtracting and dividing has to be my process, and it has to be done in that order or I get the wrong answer. So I'm going to start with what I have minus what is left over to find that answer of what I'm using. So 2/3 is going to be subtracted with 1/6. Can I subtract fractions? Yes. What do I have to have? Common denominator. Do I have it? No. So once again, if I don't have a common denominator, I would strongly suggest that you stack them so it's easier to see. Have to have the same number at the top as I have in my number sentence. If I rearrange it, I end up with the wrong answer and I end up with a negative fraction, which we aren't dealing with negative fractions yet. So 2/3 has to go on top. I'm going to subtract my 1/6. I can see that if I multiply opposite denominators, that I will always get the common denominator. But now we're getting to a point where we're going to really start getting into larger numbers. So if I start looking to see first, will that smallest one go into the largest one evenly, then I can save myself some time and some struggle with really big numbers. Because yes, indeed, 3 does go into 6 evenly, so I'm going to keep the 6 as my denominator and work with that. So 1/6 is going to be carried over. Now I got to see, well, 3 has to become a 6. I have to get a common denominator, so I know I'm going to multiply the 3 by something to get 6, which is going to be a 2. If I have 2 times 3 is 6, then I know I have to multiply my numerator by the same thing. 2 times 2 is 4. So we've been doing that for almost 2 weeks now, because it was lesson 2.2a, and this is lesson 10. So hopefully we have all of those steps in our mind. And if you don't quite yet, you might just rewatch the video for this portion, just so you have fresh in your mind how it is we get a common denominator. Now, once I have my common denominator, then my question is, well, what do I do with it? And on that paper I've given you, it says that I want to keep it the same. Once I keep it, now I look at it, I'm subtracting, and that's what I do with my numerator. So 4 minus 1 gives me 3. Well, 6 can be reduced, right? We always reduce a fraction if we possibly can, and 3 goes into both of those. So reducing, once again, dividing by the same number in the top and bottom, 3 will go into 3 one time, and 3 will go into 6 2 times. So I know I have 1/2. All right, so 1/2 is the amount of salt that's being used. But I have equal groups now that I'm going to put it in. And what's the size of those equal groups? So my second step is going to be division. I'm going to take the amount that I have. Right? So knowing what I have is the key to beginning every one of these problems. Because once I know how much I have, then I know that I can divide it into my equal groups. So 1/2 of a pound divided by, it tells me that I'm going to put it in groups of 1/12 of a pound. So I'm going to just simply divide by 1/12. Can I divide fractions? No. That's when we go back to these steps. So I know I'm going to keep my first one. I'm going to change division into multiplication. And then I'm going to find the reciprocal of the second one, which means I'm just going to flip it. Put 12 over 1. Now I have multiplication, which is the easy math with fractions. The first thing I want to do is see, can I cross reduce? I can, can't I? Because I have two even numbers diagonally one to another. So I know 2 will go into both of those. So I'm going to reduce by 2's. 2 goes into 2 one time, and 2 goes into 12 6 times. Now I'm left with just multiplying across. 1 times 6 is 6, and 1 times 1 is 1, which, that's top heavy, right? And I know that a 1 is the denominator, so my answer just has to be the numerator standing alone. So I'm going to have 6 jars because I'm going to include my label. I showed my work, I have my correct answer, and I have my label. 3 points is yours for your grade. All right, so in mathematics, we have this thing called a tangent. When we have some main math going on, and then we have this kind of like sideline that kind of touches on it. I bring that up because you're going to often hear me say, well, here's a tangent thought, or here's a tangent idea. I haven't talked to you yet really in depth about expressions and equations. So yeah, this might add an extra minute and a half to the video, but having this understanding what a question is asking me, if it says I need an expression or I need an equation, really is going to be vital to you. So when it comes to the difference, there is a very basic difference. So expressions express something. They express to you what it is that you are to do. So expressions are math problems that don't have an answer shown. That's going to be all of your basic math that you learned from the very beginning, right? Adding, subtracting, multiplying, dividing. They have a number with the symbol and it followed by a number. Sometimes it might have an equal sign that comes behind it, but if it's a true expression, it won't have that equal sign. But they don't give you an answer to work with. We can get into some really big math problems also. You're going to have a lot of expressions in junior high and high school where it looks like some crazy idea of math. We have this word sin and this word cost and multiplying by y's and numerators, and I've got this exponent, and yeah, you know what? If you guys follow along and you learn all your basic steps in mathematics, even the crazy looking math problems that you'll get into in algebra and algebra 2, you'll understand all of that very easily. The opposite of expressions then is an equation. Equation, notice what that first 4 letters sounds like. Equa, right? So we've talked about that. That just means it's going to be equal. So they're always going to have an equal sign with an answer when it's an equation. So it's a math problem that has an answer. So 5 plus 8 equals 7. Now we haven't gotten into algebra, but I'm pretty sure you could do that kind of problem. You know that I would just subtract 5 from 7, but the idea is that it has the answer with it, and then there's a missing variable on the inside, and that's where you would have to be able to solve for it. So expressions just express what it is you need to do mathematically. Equations have an equal amount for an answer, even the big hard ones where there's multi-steps where I have to do them. This is a 6th grade math worksheet right here that we'll be able to do later on this year. All right, why do I bring that up? Why this tangent idea? Because this number 1 underneath says to write an expression, and if you don't know that there's a difference between an expression and an equation, you might write it out with an answer. I don't need you to write it out with an answer. I need you to know how to write an expression to tell me mathematically what to do. So the first thing we did when we looked at this, now if you think back, I introduced to you what this answer will look like, okay, was I subtracted. And I knew that I did 2 different math problems, so I have to have something that sets that off. That should tell me that I know I have a set of parentheses. If I know I'm subtracting first and then I'm dividing, which throws out my order of operations, I know there must be a parentheses when I write that problem. Well, what did we subtract? Well, we had 2/3 and 1/6 that we subtracted over here. So I would put inside my parentheses 2/3 minus 1/6. Then we did the second step when we found that answer, and we divided. So I would just add divided by 1/12. This, my friends, is an expression. It tells me and expresses to me what to do mathematically. Subtract these fractions and then divide by the other fraction to get the final answer. This one says, suppose that Mr. Barrows starts with 1 2/3 cups of salt. Explain how you could find how many jars he fills. Well, all I would have to do is to do the same work, but replace my fractions, right? So if I started with 2/3, but now they're saying, well, he's going to start with 1 2/3, all I got to do is replace those and do the rest of the math. So where this problem would be, I would just plug in 1 2/3, and I would do the rest of the math that we had just set up. That's going to be important here in just a moment. All right, so here's our practice problems. Here's the things to look back at as you're doing your assignment. So it is important, step by step, you're following along with me. Your brain is engaged with me. Your ears are open. If you got earwax in there, clean them out, whatever you need to do. But turn your brain on, listen, and we're ready to go. All right, so the first one they give me, there is 4/5 of a pound of sand in the class science supplies. See, I love this lesson because most of it's about science. It's fantastic. If 1 scoop of sand weighs 1/20 of a pound, how many scoops of sand can Maria get from the class supplies and still leave 1/2 pound in the supply? So as I'm reading that, I should be thinking, number one, we just did a couple of those and he told me they're all going to be done the same way. But we should be thinking, okay, so I know I've got 2 steps here. I have something left over from my original, and then what I'm using is going to be put into equal groups. So going through that same process. What am I looking for? Well, I'm looking for how many scoops. Maria, here we go. And how many scoops of sand can Maria get from the class supplies and still leave 1/2 pound? What do I have to use? Well, I have to know how much she has, which it tells us I have 4/5 of a pound. I have to know what my groups are going to be divided into at the end. And it tells me that our scoops are 1/20 of a pound. And then how much do I have left over, right? Well, how much do I have left over? It says still have 1 pound of the sand left over. Okay, so I can do that. I know that I have something and I'm going to take something away because I have something left over, right? So I'm going to have to subtract and then, divide because I'm putting it into equal groups. So that's our thinking process every single time here. So I'm going to take my 4/5, always start with what I have, and then take from it what I am going to leave inside the container. So I have 4/5, and I'm going to subtract 1/2. Can I subtract fractions? Yes. What do I have to have? Common denominator. Do I have it? Yet. So now I'm going to stack these up, put the first one on top always, so I don't have to worry about negative fractions yet. I'm going to have 4/5 minus 1/2. Can the smallest one go into the biggest one evenly? 2 does not go into 5 evenly, does it? So that's what I'm going to multiply by my opposite denominators. Once again, that process always works, but sometimes I don't have to do it. This time, I do. So when I look and I have a 2 down here, I'm going to multiply up here by my 2's. When I have a 5 up here, I'm going to come down here and multiply by 5's. Always multiplying by the top and bottom so that I change my digits into what it looks like, but I'm not changing the value of my fraction. Now I multiply to get those numerators and denominators. I know that 5 times 2 is 10 and 2 times 5 is 10, so my denominators are good. My numerators I have, 2 times 4 is 8, and 5 times 1 is 5. Now I have my common denominator. What do I do with it? I keep it the same, right? Then I do my math with my numerators. 8 minus 5 is 3. So 3/10 is the amount of sand, 3/10 of a pound, that we're going to use in our math. And every scoop then has a weight of 1/20 of a pound. So I know that I'm putting it into equal groupings of 1/20th of a pound, and equal groupings will always tell me that I'm going to divide. Can I divide fractions? No, I can't. That's what this last week's been all about. So I know I'm going to go through those steps. I'm going to keep my first one. I'm going to change division into multiplication, and then I'm going to flip my second fraction into its reciprocal. I have 20 over 1. Now, can I cross reduce? I can. There's two ways to cross reduce this one, right? I can look at it and see, well, 10 goes into 20 evenly, and I can divide by 10 to both of them. Or they both end with 0, and I just cross the zeros off. Either way, I'm still going to get 1 as the denominator and 2 as the numerator. Now I'm left with multiplying across. 3 times 2 is 6. 1 times 1 is 1. And I know my answer just has to be the whole number. But what are we talking about? Well, on that problem, I know I'm talking about scoops, so I'm going to have 6 scoops as my final answer. 1 point for work, 1 point for answer, 1 point for having the correct label. 3 points every time. What if, though, and this is where I said knowing how to change these is going to be important. Maria leaves 2/5 of the sand in the supplies. How many scoops can she get? Same math, right? Same information that I started out with. She still has 4/5 of the sand. Still, we're going to be using the same scoop, which is 1/20th of a pound, but I'm going to leave now 2/5. That's where this one changes. So how do I do that one? I do exactly what I did up above, but I just change one step. Instead of subtracting the other number, I'm now going to subtract the 2/5. Still, when I look at it, common denominators, it actually makes this one a little bit easier. So I'm going to keep the 5s, and I'm just going to subtract. When my denominator is 5, 4 minus 2 gives me 2. So I know now I have 2/5. And what did I do with the amount that I was actually using? I'm going to divide by the amount that's in the scoops. So I take my 2/5 divided by my 1/20, and we know we can do it. So we've got to follow the steps. We have to keep our first one. Division becomes multiplication, and then we have to flip our second fraction. When I have my reciprocal, I see that my denominator 5 does go into 20 evenly, so I'm going to cross reduce. 5 goes into 5 one time, and 5 goes into 20 4 times. Now when I multiply across, instead of having 6, now I see that I have 8. So I have 8 scoops when I'm going to keep 2/5 of a pound left over instead of the other. Okay. So we should be seeing, as we wrap up, getting close here to the end, these are all done the exact same way. All right, so this one is talking about water. Once again, where? In the science class. There are 6 gallons of distilled water in the science supplies. If 10 students each use an equal amount of distilled water, and there is 1 gallon left over in the supplies, how much will each student get? Now, Mr. B, we've been dealing with fractions for 2 weeks. This doesn't have anything to do with fractions. Wait till we get to the answer. All right, so let's look at what we have. I want to know how much we're going to get, or how much each student is going to get. I'm going to use what I have. I have 6 gallons. What is it being broken up to? Well, it's being broken up or divided into amounts for 10 different students. And what is left? Well, I need 1 gallon to be left over in my science lab. So when I look at that then, I'm still going to set it up the exact same way, even though right now I don't have any fractions. I'm still going to subtract what I started with and what I am taking away and keeping at the end, so I know how much is actually being used. So I'm going to take my 6 minus my 1, and that's going to give me 5. Once I have the 5 then, it says that I'm going to divide it amongst 10 even students, and I only have 5. I'm not going to split my fingers in half, right? But when I do the math, if I see that I have 5 divided by 10, well, let's go ahead and change those into fractions. Let's put them both over 1 so that it makes my answer more logical as I'm trying to get to it. When I do my same steps, I know I keep my first one. My division becomes multiplication. Now I flip that 10 over 1 into 1 over 10. That's where my fraction comes into play. I can cross reduce the 5 and the 10. And when I do that, 5 goes into 5 once and 5 goes into 10 2 times. And I see that I have 1/2 of a gallon for each of my students. So now, what if you said, well, I looked at it more of a just straight division. I knew I had 5 left over, and I just divided by 10 and got a decimal. That's fine, other than when I need a fraction, because the whole entire chapter is about fractions. As long as you know that 0.5 is the same as 1/2, or 5/10, you made it into a fraction, put 5 over 10 and reduced, you still got to 1/2. More than one way to do a math problem, and as long as you get it correctly and you can reproduce the way you're doing it, that's fantastic. All right, so question 4. The total weight of the fish in a tank of tropical fish at Fish and Fur was 7/8 of a pound. Each fish weighed 1/64, that's a very small amount, of a pound. After Eric bought some fish, the total weight of the fish remaining in the tank was 1/2 of a pound. How many fish did Eric buy? So how many fish did he take home is what we're looking for, right? And we have to think about what it is that we're looking for. So we're starting with what we have at the very beginning. And it tells us that we have 7/8 of a pound. What am I dividing it into? Well, I know each fish weighs 1/64 of a pound. Seems like a crazy amount to use. And then I see that left over, I have 1/2 of a pound of fish inside the tank. So my final answer when I do my subtraction followed by my division should tell me how many fish did Eric, I think it was, take home. When I have my 7/8 that I'm starting with and I'm subtracting what I'm being left with, then I have 7/8 minus 1/2. I can't do that because I don't have common denominators, right? So I stack them. I know I have to get common denominators. I could multiply by opposite denominators, but I see that that 2 goes into 8 evenly. And when that's the case, I just keep that as my common denominator. Since 8 will work, I know I need to change my 2 into 8. So what do I do to 2 to get 8? Well, I multiply by 4. And if I multiply my bottom by 4, I have to multiply my top by 4. And 4 times 1 is 4. Now I have my common denominator, and what do I do with it? I keep it the same. So I put my 8 at the bottom and I subtract. 7 minus 4 gives me 3. So I know that Eric took 3/8 of a pound home, but that still doesn't tell me how many fish there are. So if I know that I have 3/8 of a pound and every fish weighs 1/64 of a pound, that's dividing it into equal groups, which I can't do. So I keep my first one, division becomes multiplication, and then I find my reciprocal and I flip my second fraction. Now, can I cross reduce? Well, 1 won't go into 3 without, and actually change anything, so 3 and 1 would stay the same. Well, 8 go into 64. Well, if I know my multiplication facts, it absolutely will, because 8 times 8 is 64. So 8 goes into 8 one time, and 8 goes into 64 8 times, which leaves me with multiplying across. 3 times 8 gives me 24 over 1 times 1 over 1. So how many fish did he take home? He took home 24 fish. Moving on. Now we have this rodent. I think the book likes rodents because this multiple times we've had rodents in our problems. Fish and Fur at a bin containing 2.5 of gerbil, 2.5 pounds, of gerbil food. After selling bags of gerbil food that each held 3/4 of a pound, 1/4 of a pound was left in the bin. We got a new step, don't we? If each bag of gerbil food sold for $3.25, how much did the store earn? So when I start thinking about that as I'm reading, I've had the exact same math problem every time, right? We started doing in first step, so in parentheses, what they have and what is left over, and we subtracted those. And then we divided those into equal groups. But now I got to find a cost. And if each one sold for $3.25, mathematically, what are we going to do? Hopefully what popped into your head was, well, then I'm just going to multiply. So we haven't seen these yet, but these yellow things here, they're called brackets. And anytime I have brackets, it just says that this is a second set of parentheses. So I start with the parentheses that's on the inside, do all the math that's on the inside, and then this is going to keep it all separated, because then I'm going to do my last step. So I know in my last step I'm going to multiply by the cost to get my total amount that we're making. So in my last step, my cost, I know I'm going to have to multiply. Have a lot of work to get there through there first then. So this is a 3-step math problem. So let's get into it. First, what does she have? She has what? 2.5 pounds of durable food. Okay. And then we know it's going into equal groups of what? Well, each of the durable bags hold 3/4 of a pound. All right, we got that. How much are we keeping in the store when we're done? 1/4 of a pound was left in the bin. We've got that. Same process at the beginning. I have to figure out how much we're actually talking about. So I'm going to take my 2.5 and I'm going to subtract my 1/4. Can I subtract fractions? Yes. What do I have to have? Common denominator. Do I have it? No. But Mr. B, I do have a whole number. It's all right. Doesn't change my math. My first one is still going to go on top. I know I'm going to subtract my second one. I don't have a common denominator. I can multiply by opposite, and if that's what you prefer to do, feel free to, because you're still going to get to the right answer. But I can see that my 2 will go into 4 evenly, so I'm going to stick with my 4. That's going to be my common denominator. So when I figure out what 2, I have to get a denominator of 4. This whole 2, all I do is carry it over. It doesn't change what I'm doing here. When I go from 2 to 4, though, I'm multiplying by 2, right? So in my fraction only, 2 times 2 is 4, and 1 times 2 is 2. I don't do anything with my whole number other than keep it, so I can use it in a minute. Now I've got 2 2/4 minus 1/4. Do I have a common denominator? Yes. What do I do with it? Now I keep it. Then I'm left with subtracting. 2 minus 1 is 1, and 2 as a whole number minus nothing is just 2. So I know I have 2 1/4. So we sold 2 1/4 pounds of gerbil food. In how many equal bags? So now I have to divide that into 3/4. Well, 2 1/4 can't be used in my division, right? So now we have to change it up. I know I have to start at the bottom and I have to multiply and add. Notice I already put in the symbols. I'm going to multiply and then add at the top. So I'm going to start at the bottom. Somebody had said yesterday, well, we start with the denominator and we multiply by the whole number. That's perfect. Those are actual mathematical terms. So I'm going to start at the bottom, the denominator, multiply by the whole number of 2. 4 times 2 is 8. And then I add the numerator. 8 plus 1 is 9. What's my denominator going to be? Hopefully you thought 4, because my denominator stays the same. Now I can do my next step. I have actually 9/4 if I just use fractions. And I know I'm going to put it into equal groups, so that's division. And those equal group sizes are going to be the 3/4. So if I divide it by 3/4, then I know I can't do it. So I got to go back to these steps that we've been doing all week. I want to keep my 9/4, so I keep my first one. My division becomes multiplication, and then I flip my second fraction. I get my reciprocal. I cross-reduce anywhere that I can, and finally I have one where I can cross-reduce both ways. My 4s, they just cancel out, right? And they both become 1s. That's the easiest cross-reducing that we can do. My 3 and my 9, well, 3 goes into 3 evenly, and 3 goes into 9 evenly. So I'll reduce with 3s, and 3 goes into 3 once, and 3 goes into 9 3 times. Then I'm multiplying across. 3 times 1 is 3. 1 times 1 is 1, which tells me I have a whole number of 3. I'm done, right? Nope. So I left that box there. I have to remember now what I'm finding is the cost, or the value. How much money did I make? Well, if they each cost, what did it say? $3.25 a piece. Well, $3.25 times 3, multiplying with decimals, then I know I'm going to get 9.75. So when I do my multiplication, I see that I have 2 decimal spaces. I've moved from right to left 2 times, so I know that it's $9.75. If I ended up with $97.50, or even worse, $975. To me, there's no point in having a gerbil if I'm going to spend $975 on gerbil food. So let's think about our answers and make sure they're logical. All right, so this is our assignment. I'm going to keep number 6 in case you're struggling. You can come back and work with me, but it's just understanding our story problems. Yes, it's a longer video. They usually are going to be when it's the last lesson we're doing story problems. I'm trying to walk you through our thinking process. Your assignment is up there. Make sure you do all of them. It should be shorter, but it does have a lot more steps. And please, I beg you, don't try to do all of your steps in those little itty bitty spaces they give you on these. When it comes to the story problems, I need all of you to have extra sheets of paper. Some of you do write small enough and it can fit in neatly, but I need to be able to follow your steps and thinking processes. So if you all work on just extra sheets of paper that are over here, then it's going to be easier for me to grade your assignment. If you have any questions, come back and help. If you don't, get your homework assignment done. Tomorrow's your test.